So let's divide 4 minus 5x minus x squared plus 6x cubed by 3x minus 2. Thoughts? We don't have any thoughts? Well, yeah, but maybe we should think about writing the dividend in a different order, as it's kind of backwards for the way we normally write it. That was what I was looking for. I'm sad now. This would be 6x cubed minus x squared minus 5x plus 4. You tell me. How do I need to proceed? Drunting is probably not going to get us very far.
Don't you take 3x and see how many times it goes into 6x cubed?
Yes. And how many times would that be? 2x squared would be better. Do you see how I'm lining that up with the x squared? Technically, you don't really have to do that, but it makes it look better. Then what happens? Yeah, you got to distribute it. So 2x squared times 3x minus 2. If it helps, write that out. If it doesn't, just do it. So anyway, that would be what? 6x cubed minus 4x squared. And this is the spot where changing the signs and adding is going to be a really good idea, because when you're subtracting, chances are you'll see it with the 6x cubed, but you'll already see this minus here, and you'll just subtract, whereas if you're subtracting this whole thing, this is going to turn into plus. So minus and plus. What will I have then? And then I can bring down the minus 5x. I can technically bring down the 4 if I want to. I don't necessarily need it, so I'll bring it down later. Now what? Don't everybody answer at once. Yeah, so how many times does 3x go into 3x squared? X. So this will be plus x. X times 3x minus 2 would be 3x squared minus 2x. Change the signs. Add. And I get negative 3x plus 4. Now what? Don't make Kylie answer all the questions. Somebody else step up. Let's go. Not quite. How do I make 3x into negative 3x? Negative 1. So if I have negative 1 times 3x minus 2, That's going to be negative 3x plus 2. Change the signs, add, and you get 2, right? How do you know when to stop? Right there, why? Yeah, 3x doesn't go into 2. So, at that point, 2 is your remainder. So you're going to come back up here and you're going to go plus 2 over 3x minus 2. And this would be your answer right here. Therefore, if you wanted to write it like this, you could say that 6x cubed minus x squared, crap, what was it? Yeah, minus 5x plus 4 divided by 3x minus 2 is equal to, I forgot what the answer is, 2x squared plus x minus 1 plus 2 over 3x minus 2. There's a reason why I wrote that again. I'm going to come back to it in a minute. So maybe leave yourself a line or two of space. Now, this brings up what's called the division algorithm. The division, almost couldn't spell there, algorithm. All right. So let's pay close attention to this. If f of x and d of x are polynomials, with d of x not equal to 0, because we're dividing, so I don't want to cause division by 0, and d is the divisor. And the degree of d is less than or equal to the degree of f. Then, and I'm going to use a slightly new symbol here, so pay attention. There exists a unique, meaning not only does one exist, but there's only one. Q of x and R of x polynomials such that f of x is equal to, how do I want to write this? D of x times Q of x plus R of x. Now, let's understand what this says. This guy right here is the dividend. That's the one you're dividing into. This is the divisor. This is the quotient. And that's the remainder. Basically, what the division algorithm is saying is that when you do this division here, the quotient and the remainder are unique. So like, for instance, on the problems we already did, if if you do your math right, everybody should come out with the same answer in the end because that answer is unique to the two things I'm dividing. Now this is written kind of funky. That's why I want to go back and show you how to get this from what we already had. Okay? So I'm going to come back to this in just a second. If we go back a screen, if you take this and multiply both sides by the divisor, which would be 3x minus 2, on the left-hand side, the 3x minus 2 is going to cancel, and you'll just have 6x cubed minus x squared minus 5x plus 4. So that's your f of x from the other screen. Then you're going to have, when I distribute the 3x minus 2 to this side, the right-hand side, I'm going to have 3x minus 2 times 2x squared plus x minus 1. So that's your d of x, the thing you're dividing by, and that's your q of x, which is your quotient. And then notice if I multiply the remainder part by 3x minus 2, the 3x minus 2's are going to cancel, and I'll just have plus 2, and that's r of x. So that's how you rewrite this expression to look like the expression from the division algorithm. Now, more often than not, you wouldn't need to do that, but there's a reason why it's written that certain way, and I'll explain that later on in the lesson and or tomorrow. All right, so back to the division algorithm. So, r of x equals 0, or, because obviously the remainder could be 0 if something divides evenly, right? So it's either equal to 0 or has the degree of r strictly less than the degree of d. Why would the degree of the remainder have to be less than the degree of the divisor? Say what? Right, because if it weren't less, you could keep going. Because the remainder is what you get when you can't divide anymore. So notice that in this problem right here, the divisor has degree 1. So the remainder had degree 0 because it was just a constant. That's important. So the degree of the remainder has to be strictly less than the degree of the divisor. If r of x is equal to 0, d of x divides evenly into f of x, which makes sense. And d of x and q of x are factors of f of x. So that's extremely useful, understanding that if the remainder is 0, then I've got two factors, essentially. And I mean, that makes sense, because if you come up here, I'll scroll back down in a minute. If you come up here, if there's no remainder, then you literally end up with f of x equals d of x times q of x. That's factored, at least partly.